So today's lesson is we do this short circuit calculation. So short circuit current calculation. The short circuit current calculations we can use a formula. The formula is a normal full load current divided by the percentage impedance multiply 100. This means that normal full load current is any motor or any transformer. They are taking this normal current at a full load condition. So that normal current is divided by the percentage impedance and then we multiply with 100. So this is the way we can calculate the short circuit current. So then we do this one example problem. 11 kV slash 400 volt delta star 600 kV transformer equals a percentage impedance of the 6%. And then we have to calculate the rated current and also fault current at the secondary and also the fault current transformers are impedance. So those fault current at the primary and also the transformer impedance has to be calculated. So that we draw the circuit diagram here. So that will be the primary is a delta connection, secondary is a star connection. So 11 kV is an input, and 300 kV and the 400 volt is a secondary. Primary is a delta connection, secondary is a star connection. In this case, our percentage impedance is given the 4%. So we have to calculate the normal primary full load current. Primary full load current is transformer kVA given the 600 kVA. So the 600 divided by the 3 phase, so divided by √3 and the voltage, line voltage. So that will be the 11 kV. So the 600 multiply kVA, so 10 power 3 and √3 is 1/7321. 11 multiply kVA is 10 power 3 multiplying. So we calculate, so that we got the 31.49 ampere. So this is for the primary current. And also we also have to calculate the secondary current. Secondary current also kVA is 600 kVA, 600 multiplied 10 power 3, √3 is 1/7321, and secondary voltage is 400 volts. So divided by 400, you got a 866 ampere. So therefore the primary current is 31.49, secondary current is 866 ampere. Then we have to calculate the fault current. Fault current of the secondary. So fault current of the secondary is the secondary's full load current is we calculate this 866 and percentage impedance is 4%. So 866 divided by 4 multiplied 100. You got the 256.1656 ampere. So this is for the short circuit current we can calculate. Then also we can calculate the fault MVA. So the fault MVA is MVA SA. Short circuit currents are 4 MVA and divided by the MVA full load is divided by the percentage impedance and multiplied with 100. Therefore, we calculate that we substitute the MVA full load is 600. So we substitute 600 and divided by 4 and 100. You got the 150, 15,000 kVA. We got this is the 4 MVA. Then we also have to calculate the percentage impedance equation. So the percentage impedance equation is a percentage Z equal to the full load current multiplied phase impedance divided by the phase voltage multiplied with 100. In this case, IFA is a full load current, ZBA is an impedance bar phase, EBA is an impedance bar also phase voltage. So we have to substitute the those factors in this equation so we can calculate the thing. So therefore we substitute the percentage Z. So those things we substitute. So the primary impedance have to be calculated. So primary impedance is in this case the primary percentage impedance is a 4% given, and this will also have to calculate the I full load current. Full load current means a phase current. So primary is a full load current. We have to already know that 31/49. This is for the data connection. For the data connection, phase current is a line current divided by √3. So we got 31/49 by √3. ZBA we had to find out. EBH is a line voltage. Line voltage primary line voltage is EBH is a phase voltage. So that this is the data connection. Phase voltage and line voltage are equal. So that this is the phase voltage equal to line voltage equal to 11,000. So we substitute 11,000. So everything we substitute, you got the primaries are phase impedance we calculate 24.2 ohm we calculated. Similarly, we also calculate for the secondary. Percentage Z equal to IFM divided by ZBH by EBH into 100. So the percentage Z is a 4 and full load current is a secondary line current given the 866. This is also equal to phase current because of the star connection. So this is the current 866. ZBH is unknown. Phase voltage have to calculate. So line voltage 400 for the star connection. Phase voltage line voltage by √3. 400 by √3, and then we calculate. So you got the 13.94. So this is the way that we calculate for the primary and secondary phase currents are line current and also percentage impedance, phase short voltage, short circuits are current, and then short circuits are MVA. We can calculate it. So here will be this electric gas distribution system. So supply is a power supply, and then we have to install the protection devices. Protection devices will be the circuit breaker or the fuse. Those have to be connected, and then also we have to connect the wire line and then connect it to the equipment. So this is the according to the standard connection diagram. In this case, we have to follow the every protection equipment. So this is the commencement of the circuit. From this circuit, final circuit, this is the protection equipment, the commencement of the circuit. So, and these protection equipment, we have to utilize a cross 2.5/2 of the AS3000. So this AS3000 cross 2.5/2 mentioned about the circuit breaker or fuse must be operated before fault current cause the system and cable to reach the temperature limit. So this is important. So this is before the fault currents are reaching the temperature limit of the cable, all the circuit breaker, all the protection devices must operate. So this is the clause 2.5/2 of AS3000. Those things have to be followed. So nowadays this is included in the temperature limit. You can find out the cable temperature limit in the AS3008 section 5. So it mentioned about the cable temperature limit. And fault current impedance is also calculated the equation. Fault current is a normal current divided by percentage impedance into 100. In this case, our fault current calculated normal current. How we calculate transformer rating kVA divided by √3 into line voltage, and then 100 multiplied 100 divided by percentage impedance. This is the way we calculate the fault current. So this is this transformer. The distribution transformer is connected, and then we go to this is the line, and also this is the bus bar, and then also find the equipment secondary connection, and also equipment like this. So the distribution transformer is a 500 kVA rating, and percentage Z is a 0.045 ohm is with it, and also this is the line is Z impedance is 0.004 ohm, and also this is for the line current, secondary current also given. So in this case, firstly we had to calculate the full load current. Full load current is a kVA divided by √3 into line voltage. So this is the kVA 500, √3 line voltage is 400. So in this case, you got this 721 ampere. And percentage impedance also calculated. Percentage IFM multiply ZPH divided by EVA to 100. So in this case, IFS is a percentage Z have to calculate full load current 721, and also the ZBH here given that the 0.065 ohm, and divided by the EVH voltage is a 230 volt, then you got 11.29. Similarly, this percentage impedance also calculated. So this line current is 721, this impedance is 0.004, divided by the 230 is a line phase voltage and 100. Also, this percentage impedance also have to be calculated. In this case, the line current is a phase current 721, and here is a 0.006, 0.036 into 721 into 100. So you got calculated. So this is the way we calculate the percentage impedance. And also the primary short circuit current can be calculated. So the primary full load current is 500 MVI to root 3 to 4 divided by 400. This is the primary full load current. And here is 11.49 is the percentage X, Z, and multiplied with 100. So this is the current in this line, the transformer short circuit current calculated. Similarly, we also calculate the short circuit current of this part. This one is a total current is a this total supplying a normal full load current, and we also have to calculate that this 11.89. 11.89. So this one is a this transformer impedance and the line percentage impedance have. So transformer impedance is 11.89. Line impedance is 1.25. So 11.89 plus 1.25. We calculate it. And also this one fault current. Fault current is the line current is the same, but the impedance are the transformer impedance, percentage impedance, line percentage impedance, and line 2 percentage impedance. So transformer percentage impedance 11.29. Line 1 percentage impedance is 1.25. Line 2 percentage impedance is also 8.6. So this is the way we calculate for the fault current. So this is the way we calculate for the fault current level of the different point. So this is for this program. You can look at this program and then you can see it. So another thing is a prospective fault currents value. So this means you can determine how much fault current happen when the electrical faults are arising. So this is a residential is a 10 kilo ampere. This is for the prospective fault current rating. We got every residential equipment. So prospective fault current can rise up to the 10 kilo ampere. And for the commercial and the industrial application, the prospective fault current will be the 25 kilo ampere, and also the railway length. So railway is a 6 kilo ampere. So this is the prospective fault current value. It can be reached to the test value. So we have to determine the circuit breaker side. So in this case, the circuit breaker side must be the appropriate to the prospective fault current. So this is the formula we have to utilize. In this case, T equal to K square S square divided by I square. T is a time. In second, K is a material factor. S is a conductor cross-sectional area. I is a effective short circuit current. So those formula can be utilized to determine how much time taken for the circuit breaker and protected devices to operate. So that's protected devices operation time T is dependent on the materials factor and also conductor cross-sectional area and the affected short circuit current. So this is the circuit breaker side and the KVL side, and choose size to calculate the prospective short circuit current. Now thing is we have to calculate the flow area. So in the design diagram, flow area to KVA conversion can be utilized. So the AS3000 2018 table C3 has to be utilized. In this case, a switchboard side and a circuit breaker side, current circuit arrangement have to be utilized. So in this case, AS3000 addition. So table 8.1 is talking about the circuit breaker rating and for loop impedance rating. So this is about how the circuit breaker rating and for loop impedance ratings are related. So this is why we have to look at the tables 8.1 of the AS3000. So So this is for the table 8.1. Table 8.1 on the AS3000. So this is a protected device rating. Also, that we have utilized a circuit breaker type B, type C, type D. They are operation type, and this is the for loop impedance. And also the for on fuse on the final circuit. This is the Q rating, and this is for loop impedance. So that you know the for loop impedance, and you know the protected device rating, and you can determine the appropriate circuit breaker size. So this is the way we have to calculate the appropriate matching between the protected device rating and the circuit breaker. And also we install the light point and socket outlet and equipment. And also for the lighting point, we have to determine the illumination level. In the meantime, so that depending on the illumination level, we have to determine how many light points will be required, and then we have to determine the appropriate circuit size. And circuit breaker, fire protection, smoke detector, alarm need to be installed in the area. And then depending on your lighting and the socket outlet side, we have to determine the cable selection. Cable selection, if we have to utilize it, is a 3008 rule. And then we also have to calculate the voltage drop calculation, cable installation method, reference rule regulation. Then we utilize the AS 3000 rule. So this is the ways that we calculate and solve the problem. So the AS 3008. So this is the ASR 3000 New South Wales Electrical Service rule. So this is the way we have to utilize the AS3000 rule to calculate the cable size. AS3000A is a cable selection. So those things we have to calculate. The next one is we determine the size of the fuse. Size of the fuse can be calculated. So the fuse is when the electrical current flow into the fuse wire, this current will reach the certain temperature limit and the fuse will blow out. So therefore the heat energy is produced by the fuse need to be calculated. So the equation I square RT equation. So I is a current, R is a resistance, T is a time. So the fuse is allow the normal current, but the blowout when the excessive current is reached. So normal currents are the starting current of the induction motor. Because of normal current are short current, short time current because of the loss for the long time current. This is only the short period of current will be risen because induction motors are three-phase induction motors are draw the 4 to 5 times of full current. So therefore the fuse should withstand for the time because of that. When you start a three-phase induction motor, the current will be higher than the normal current. It can be risen up to 4 to 5. So this will be the little just a very few seconds. The current will be risen. So therefore the fuse need to be withstand for the current. So this is the normal currents are calculated. And then the fuse characteristic is depending on the current rating, voltage rating, and the time current characteristic across through the T equal to the Heat equal to I square RT equation. So current rating, voltage rating, and the time current characteristics are determining the fuse characteristic. So the fuse the current operation time can be analyzed to the two factors, pre-arcing time. So the time required for the blowing out, arcing time means the time taken by the occurrence of the arcing. So they are pre-arcing time and arcing time. So fusing factor is calculated maximum fusing current divided by current rating of the fuse. This means that this is a normal circuit here. Here, black waveform is a normal current, and red waveforms are the fuse current. So the before flow currents are reaching the peak value, the fuse should be blown out. So this is the cutoff point. Cutoff point, the fuse should be blown out. So this die is a pre-arcing die. So that from here to here is the arcing die. So the frame will be this is the arcing diagram. The arcing die is here, and then for happen, so this is the arcing die. So the pre-arcing die and the arcing dies are combination is to the die taken by the required by the fuse to operate. So therefore the fusing factor is important. So the tables are 8.1 of the AS3000 rule. So it shows about the operation time of the circuit breaker and fuse. For example, if you see the 32 and 63, so this rating you see 32 is a quotidian operating current and is a motor, 63 is a reliable starting current, inverter characteristic. So this is the thing you have to understand. And then here is a fuse blowout is this is a prostatic short current. But here before reaching the maximum point, fuse need to be blown out. So this is the pre-arcing die. Our blowout current will be cooling down. So this is the arcing die. So this is the fuse blowout, arcing die, and pre-arcing die. And the prostatic currents are diagram. So this combination of the pre-arcing and the arcing die is operating time for the fuse. So we have to calculate the up force of protection. Equipment need to withstand the short circuit level. This is the IB rating, insulators are rating, and also the protective equipment need to be provide full protection before damage. So those are the important for the for protection. So the short circuit current is calculated by this formula. IF divided by percentage Z into 100. IF is a short circuit current. IF is a normal full current. Percentage Z is percentage impedance. So the fuse characteristics are the inverter characteristics depending on the type of fuse. Horizontal is a time, vertical is a Arkansas MBR. So the short circuit current MBR for current will calculate it. So this way the diagram can be drawn. In this case, we can set up the operating time of operate, and then we can determine the appropriate for current level. So this is depending on problem for current level, and depending on the type of fuse, we can determine the operating time to operate. So if you know the time to operate, we can then select the appropriate circuit breaker side or fuse side. So this means the for loop impedance is important because the for loop impedance determines the short circuit current value. So the for loop impedance ZS can be calculated by the U0 by IA. So U0 is a for loop impedance. Normal operating voltage. This is U0. ZA is a for loop impedance. IA is a current causing the automatic operation of the protected device. So in this case, this diagram, horizontal is a fuse current rating, vertical is a current required to blow at the fuse. So this is the way we calculate the thing. So touch voltage limit is a 50 volt AC or the 120 volt DC. So this is the way we calculate for the touch voltage. So this is for the connection of the final sub-circuit. So this is the main switch and also sub-circuit. Sub-circuit operation is this is the sub-main, and here is a final sub-circuit. Final sub-circuit include the socket outlet and the lighting board. In this case, a sub-main operation is need to be operated within the 5 seconds. Final sub-circuit 0.4 seconds for the fusing protection. So this equation is the K square S square must be greater than I square T. So K is a factor, A is a cross-sectional area of the fuse element, I is a current, and T is a fusing current die. So this is the A plus C fuse characteristic equation. We have to follow K square S square must be greater than the I square T. K is a factor, fusing factor, A is a cross-sectional area of the fuse element, I is a current, T is a die. So this is the way we have to calculate. So this is for the AS 3008. AS 3008. So electrical installation cable. So those things have to be calculated. This AS 3008 is have to be utilized to calculate your cable size. The next one will be that we calculate the this for the fuse currents are characteristic of the fuse. So this is for the this line graphs are determined as a fuse characteristic. This is for a circuit breaker. This one is a circuit breaker characteristic. So this point, the red point is the circuit breaker operation cut-off time. So time characteristic. So this time is determined by the time characteristic. Maximum load current rating and also need to operate the circuit breaker. So the circuit breaker operation cut off the current. So this is what this current characteristic is fuse and the circuit breaker characteristic. So horizontal is determined current, vertical line is a tie. So in this case, a circuit breaker operating mechanism is operated by a thermomagnetic and thermomagnetic function. So this way the derating. Derating means that we have to sometimes we have to derate the circuit breaker. So in this case, for example, 10 ampere circuit breaker, we can only utilize 8 or the 7. So this is for the thermal circuit breaker, this derating pattern. So we have to use unsatisfactory for the short circuit protection. Plus backup fuse for the protection. This is also have to utilize. Sometimes only circuit breaker is not enough. So we have to utilize the backup fuse protection. So this is for the thermal circuit breaker protection. When the electrical current reach the predetermined value, it can reach the temperature and then it can cut off the trip off the circuit breaker. So this is what the circuit breaker connection. So magnetic circuit breaker is we determine the magnetization. So the magnetization cut off the circuit breaker contact. Here will be the when we circuit breaker operate, so it can cause the electric arc. So that electric arc need to be extinguished. So that what we do is for the small circuit breaker, we utilize a magnetization. So the magnetizations attract the electric arc, and they are those electric arcs are cut off by this bar, and the electric arc will be cut to the pieces, and then air is blowing, and then we extinguish the electric arc. So this is the way we make the protection. Okay, this problem, to find a circuit, supply a load consisting of the 10 ampere socket outlet and protected by the 16 ampere DC circuit breaker. The internal follow impedance measured at the port short circuit outlet is 1/2 ohm. We have to determine the value of the internal fault impedance satisfy the requirement of the ASR 3000. So in this case, we know about the fault circuit current. So this is for the protection, the 16 ampere circuit breaker, and then type C circuit breaker. So we look at the ASR 3000 rule. So this is ASR 3000. So the type C circuit breaker 16 ampere. So that will be the 1/9. Follow impedance must be the 1/9. So 1/9 ohm. So this is the follow impedance we calculated. So then for that we got the 1/9 ohm. So that will be the 1/9 ohm, the follow impedance. And socket outlet impedance is 1/3 ohm. So this is the measure value is 1/3 ohm. That will be table value is 1/9 ohm. So measure value is less than the table value. So that will be satisfied the 3000. Because of the when we this is the accurately measure the follow impedance. This is for the table. From the table, we know the circuit breaker rating and the type we can calculate. So that value must be greater than the real measure value. So if table value is greater than measure value, it satisfies the 3000. So this is the way this problem is solved out. So this problem is from the table 8 by 1, we have to determine the maximum value of the follow impedance to cause the fuse latest below to operate in the nominated die. So this means the fuse rating is 10 ampere. Required tripping time is 0.4 ohm. So the 10 ampere, 0.4 ohm. We have to determine the follow impedance. So follow impedance, so we have to see that this one. Fuse rating is a 10 ampere, tripping time is a 0.4. So fuse rating is a 10 ampere, tripping time 0.4. So 10 ampere, 0.4 second. So that will be 6.4 ohm. So this 6.4 ohm, we calculate that. So that this is just a follow impedance. Supply voltage 230 volt. So 230 divided by the follow impedance, you got the current. So 35.4 ampere. So 4 current we calculated. Similarly, fuse rating is at 10 ampere, tripping time is 5 seconds. So we look at fuse rating is at 10 ampere, tripping time 5 seconds. So in this case, you can see the 9.2 ohm. The follow impedance 9.2 ohm. So just follow impedance 9.2 ohm. So we substitute. So supply voltage 230, follow impedance 9.2. So you got the current. So this 4 current is 25 ampere. So this is the way we calculate it. The next one is a 2.2 ohms quick recovery water heater. 2.2 kilowatt quick recovery water heater. So this water heater is protected by the HRC fuse protection. In this case, we have to utilize V75 cable. So operating temperature is 75 degrees centigrade. So that we have to find out the maximum current and the fuse to protect and the current carrying capacity of the cable. Those has to be calculated. So that in this case, the cable is a partially surrounded saturation. So this is the enclosed saturation. So that will be there's a ID, maximum demand current must be less than the protected device rating and it must be less than the cable rating. So those things has to be know about. And also the I2 is the operating current must be less than the 1 by 4 by the IZ, so cable rating. So this is the two formula must be for the certified. So the cable is a 1.5 millimeter square cross in the area. The arrangement for the short circuit protection is have to be done. So the AS3000 tables are C1, C2, C3 has to be utilized. So in this case, that condition, the domestic equipment are maximum demand condition. So the AS table C1, page 464 has to be utilized. So table C1, page 464. Okay, this is a low group current calculation. So that in this case, the power is given the 2.2 kilowatt, supply voltage 230 volt. So that from here we calculate the current is a 9.65 ampere. 9.65 ampere we have to calculate. So we have to take the full load current. Full load have to utilize. So table C1 page 40 quick recovery water heater. Quick water recovery water heater is low group F. So you see that table C1. You see the quick recovery water heater. Low group head, slowly water heater. So slowly water heater, quick recovery water heater. So this is a low group F. So across the room, the single domestic installation from the table C1. So that will be the full load current have to be calculated. You have to take the full load current. Therefore, how to calculate the full load current? Full load current is a power 2.2 kilowatt divided by voltage 230 volts. So you got a 9.65. So that we take that this current 9.65 ampere. So this 9.65 ampere have to be calculated. So we have to find out there's a fuse current. So in this case, we have to utilize the table 8.1. Table 8.1 or AS3000. So this is the table 8.1. Move and find out the table 8.1. So 466. table 8x1. So this is table 8x1. So the 9x5 is that we can take the 10 ampere. 10 ampere rating. So 10 ampere is that we have to utilize. So 10 ampere rating. And then so this 10 ampere rating is that we have to calculate the circuit breaker. So in this case, the nominal current is IN. Circuit breaker rating is 10 ampere. So that is greater than the real maximum demand current. So 10 ampere is greater than 9x56. So we have to dissatisfy. And also the IZ, we have to find out the impedance. So in this case, we have to find the AS of 3008. So from the AS 3008, so later time I will talk about the AS 3008. From the AS 3008, table 4 column 18. So this table 4 column 18. So the 1.5 millimeter square is the cable size 40 ampere. So this is IZ 40 ampere. So therefore the IZ 40 ampere and also the IN is 10 ampere, IB is 9.56. So this is the way we determine the cable size. So later guys, I will talk about the AS of 3008. Okay, so at this stage, I have already explained about the maximum demand calculation. So maximum demand calculation is we have to utilize the table C1 page 464. So the table C1 page 464. So there will be the 464. So this is low group is a F because of the storage water heater, the quick recovery water heater. So single domestic installation, we have to take the full load current. So full load current, if we can calculate the full load current, then will be the power is at 2.2 kilowatt divided by current is at 230 volts. So 2.2 multiplied 10 power 3 divided by 230. So 9.56 ampere. So this is the we calculated. And fuse calculation. Fuse calculation, where do you utilize the tables 8.1. Table 8.1 or the AS3000. Table 8.1 is located at the page 433. Then, so in this case, we have to take the mode. So the 10 ampere. Because of the current is a maximum demand calculation in 9.56. So the protected device rating, we have to take the little more. So 10 ampere we got. 10 ampere. And then so this is the way we calculated. 10 ampere we calculated. So then we have to utilize a type C circuit breaker. So the 10 ampere we calculated. So this is the we take the 10 ampere. So there will be the circuit breaker rating is greater than the maximum demand current rating. So this is certified. Then we have to utilize the real cables installation. So the cables are installed. We have to calculate their current. So this is design current. Where to supply IZ have to be calculated. So we have to determine the cable size. Cable size we have to utilize the AS of 3008. So 3008 are that they are cable installation. There are two kinds of the cable installation. We install the cable in the air, or that we can install the cable in the underground. So cable installed in air can be the unenclosed or the enclosed. Unenclosed means the cable just there are no insulation protection. We just run the cable on the cable tray. Enclosed is we are rubbing the cable with the insulation. Similarly, the underground there will also be the enclosed and enclosed. Underground, unenclosed, we lay the cable in the underground tap. Enclosed means that we put into the underground contour on the rub the insulation. So there are four kinds of the situation. So the AS3008, there are the four situations. If you install the cable in the air unenclosed, we have to utilize the cables table 3x1. Cables are installed in air enclosed, we have to utilize the table 3x2. Cables are run underground unenclosed at table 3x3. Enclosed at table 3x4. So those four tables are the major table. So now I will look at the AS3008 rule. So this is AS3000. So this rule is for the cable installation and the selection of the cable across to the Austrian standard. So that we have to look at the cables 3.1, 3.2, 3.3, 3.4. So four tables have to be utilized. They are major table. 3.1 and 3.2 for the installation in the air. 3.3 and 3.4 for the installation underground. So that will be the cable selection. We have to use the tables. Topic 3, current rating capacity, section 3. So table 3.1 and 3.2, 3.3, 3.4, we have to find out. So then we look at the table 3.1, 3.2, 3.3, and 3.4. So we look at the table here. So those 4 tables are the major table. Table 2. Here is table 3.1. Schedule of the installation and the methods. Method for the schedule of the installation and method for the cable. Then you have the same current carrying capacity. So you at the end you see the unenclosing air. Unenclosing air, we use a table 3.1. And then also the table 3.2. Enclosing air. Table 3.2. And table 3.3 is a vary in the underground. Table 3.3. Underground wiring enclosure. Table 3.4. So there are 4 kinds of the table we have to utilize. So table 3.1, 3.2, 3.3, and 3.4. 3.5 is a 3.1 unenclosing air. 3.2 enclosing air. 3.3 is a unenclosed underground. 3.4 is enclosed underground. So there are 4 kinds of the table we have to utilize. So in this case, this water heater. In this case, all the water heater electrical cable we have to rub with the insulation. So this is the thermal insulation have to be rubbed on the cable supplied to the water heater. Therefore, partially surrounded with the insulation. Therefore, we have to utilize it. Cables are running in the air, and also they are rubbed with the insulation. So they are enclosed. So they were 3.2 have to be utilized. They will have to be 3.2 have to utilize. So they also have to utilize a water heater, single phase water heater. Single phase water heater is this is a 2-core cable. 2-core cable, single phase water heater. And also cable are partially surrounded, enclosed in air. So this is the table 3.2 have to utilize. So you see the table 3.2. We look at the table 3.2. They are item 1, 2, 3, 4. So in this case, 2 single core cable, we have to utilize item 1. 3 single core cables are item 2. 2 single core cables are also utilize all the partially. This is for the conduit, and this is the surrounded with the. This is for the surrounded with the insulation. And 3 single core cable surrounded with the insulation. This one. 2 single core cable nothing in conduit is at this one. 3 single core cable not in conduit this one. So this is the item 1, 2, and 2 core cable here, 3 core cable. So now we are using the single core cable, not 2 core, 3 core, so that we only interested in the from the item 1 to 6. So 3 single core cable or 2 single core. 2 single core cable, we can select the item 1 or item 3 or the items are 5. So this is the thing 1, 3, 5 have to be selected. So which one should be suitable? Item 1 is a under enclosure. Under item 3 is a we put into the conduit as well as a partially surrounded with the insulation. And under item 6 is a not in conduit, just surrounded with the insulation. So this program, the cables are running in the conduit, also partially surrounded with the insulation. Therefore, the item 3 is the most suitable. So item 3 is most suitable. So in this case, we have to utilize that one is suitable. So that we have to further look at the table 4, 5 and column 18 into 19. Table 4, 5, column 18 to 19. So table 4 for the V75, table 5 for the V90, and table 6 for the V110. So we look at the table 4. So in this case, derating factor is you can look at the table 22. So those tables are have to refer the further tables. So this problem here, we got the partially surrounded insulation. So therefore, the table 4, 5. So table 4 for the V75, tables are 5 for the V90 and tables are 6 for the V105. So this is operating temperature. So that here we use an operating temperature is 75 degrees centigrade. Therefore, that we have to utilize a table 4. Table 4, column 18 to 19. So table 4, column 18 to 19 has to be utilized. Table 4, column 18 and 19. So we look at the table 4 here. We find out the table 4, column 18 to 19. So here is a column, table 4, column 1, 2, 3, 4, 5, 6, up to 13. So we don't use it. 18, 19. So these are 18 and 19. So this is a partially surrounded by the thermal insulation. So table 18 for the aluminum copper conductor, 19 for the aluminum conductor. So in this case, we are using the copper conductor. So therefore, the cables are 18 had to be utilized. They were had to utilize. Cable size given as a 1.5 millimeter square. In this case, 14 MBR is suitable. So this is the way we calculate it. So that you see the thing, table size is IB is a 9/5 because of that problem given the 1.5 millimeter square. So that therefore here utilize a select the cable size. So the 1.5 millimeter square here and current rating is 40 MBR. We find out the table 18, column 18. So that then therefore that we select the thing. So therefore the cables current is a 40 MBR IZ and nominal current of the circuit breaker is 10 MBR and maximum demand current is 9.56 MBR. Therefore, it agree with this formulation. This means the real cables current rating must be greater than the protected supply rating must be greater than the maximum demand current rating. So IZ must be greater than IM must be greater than the IB. So that also agree with this formula because this problem, the cables are maximum demand cables, real cable current is at 40 MBR IZ and circuit breaker rating is at 10 MBR IN and the maximum demand current rating 9.6 MBR are IB. So this also agree with. Therefore, that we utilize the cables are 1.5 millimeter square 10 MBR. Okay, so this is for the 40 MBR we calculate, but the 1.5 millimeter is too small, so that we have to utilize a appropriate derating factor. So appropriate derating factor means we find out that this derating factor is we can utilize a that must be the 4 millimeter square. So one step side greater we have to utilize. So the after 1.5 we got the 4 millimeter square we calculate that. So that because of why we have to utilize this one way, we also have to multiply with the IZ multiplied 1.45. IZ multiplied 1.45 is we got the IZ is a 40 MBR multiplied 1.45. You got this 20.3 MBR we got. So therefore the second condition is this condition. Operating current must be less than the 1.45 times IZ. So this is the thing. Operating current must be less than the 1.45 times IZ. So operating current of the circuit breaker. Operating current of the circuit breaker is 10 MBR. Okay, so there's the 10 MBR here. And so 1.4 IZ multiplied 1.45. IZ multiplied 1.45 is this one. 20.3 MBR. So also the agree with because of the 1.45 multiplied IZ is also greater than the operating current at 10 MBR. So this also agree with. So therefore we substitute this for this equation. So everything agree with. But if you want to do the derating factor, you can select the one cable side greater. So instead of selecting the 1.5 millimeter square, we can select the 2.5 or 4. This is the way we calculate the cable size. Okay, so this problem is a cable selection problem, typical circuit installation and the cable selection problem. So in this case, how to determine the operating current as well? How to determine the operating current is we use a HRC fuse. Approximate table 8x1 is a 6.39 ohm. So this is the table 8x1 of the HRC fuse. So HRC fuse is 16 ampere. In this case, impedance Z is a 6.39 ohm. So here is HRC fuse. 16 ampere, so this is 6.39 ohm. So this is HRC fuse here. So the protected device rating 10 ampere. In this case, the protected device rating 10 ampere is, we already know it. And then also the 6.4 ohm. So this is what the HRC fuse is a 6.4 ohm is a the follow impedance. So this HRC fuse follow impedance we utilize. So supply voltage 234 divided by 6.4, you got the 35.94 ampere. This is what the I2 value. So that I2 value must be less than the 1.4 by IZ. So if you want to select the 1.4 by IZ, what should be the IZ value? So this will be divided. IZ must be greater than the 24.8 ampere. So this means that cable rating must be greater than the 24.8. So the cable rating must be greater than the 24.8 ampere. Here is AS3008. You look at the here. If you select only the 1.5 millimeter square, only cable rating is 40 ampere. If you select the 2.5, 20 ampere. If you select the 4 millimeter square, 25 ampere. This is why we select the 4 millimeter square. Because we have to satisfy with the two conditions. One condition is IZ must be greater than IM must be greater than ID. So according to this condition, we select the cable side. So in this case, IB is 9.56, IA is 10, IZ is 14. So if you select the IZ 14, cable side 1.5 millimeter square, it agree with the formula. But it does not agree with the second formula. Second formula, I2 is less than the 1.4 by IZ. How to calculate the I2? According to the I2 calculation, we use a table 8x1. In this case, protected device ratings are 16 ampere HRC fuse utilized is given the problem. In this case, for the HRC fuse, its following impedance is 6.39 ohm. So here, following impedance is 6.39 ohm. 16 ampere followed. Protected device are 10 ampere. Following impedance is 6.39 ohm. So 6.4 approximate. So this following impedance, we use a substitute into the supply voltage. So the supply voltage is at 230 volt divided by the following impedance 6.39 ohm. So you got the 35.94 ampere. This is I2 value. So the I2 is at 35.94, greater less than the 1.4 by the IZ. So from here you got the IZ is must be greater than the 34.94 divided by 1.4 by the 24.8 ampere. So IZ must be greater than 24.8. So this is why that we can select the IZ at 10 14 ampere equal for the 1.5 millimeter square because it does not agree with the second formula. Therefore, we look at the ASR 3008 table here. ASR 3008 table. So we can use a 1.5 millimeter square because of the current is 14. 2.5 also only 20. 4 millimeter square is 25. So this is why we select the 4 millimeter square. So this is a cable selection. Also, they comply with the circuit protection. So these problems are explained about the cable selection. Also comply with the circuit protection. Okay, for the electrical engineer aspect, engineer practice aspect, what I explain is that today I explain about the protected device rating, maximum demand current calculation. I explain about also I explain about the arrangement of the protected devices, protected devices can be the short fuse or the circuit breaker reading. I talk about the percentage impedance calculation. We calculate about the maximum fault current reading. We talk about the maximum fault current reading, percentage impedance calculation. We also talk about the how the factor affecting the installation of the fuse, and also the fuse rating, also the fuse characteristic current reading, voltage reading, time current reading, also the fusing currents determination. We talk about the arrangement of the for loop impedance, and also we talk about the circuit breaker operation, how to protect the circuit breaker, also how to extinguish the fire, also the arrangement of the cables protection device rating. So in this case, there's two formula agreement must be agreed with the two formula to determine the appropriate protected device rating. And also I talk about the how to determine the maximum demand current by using the table C1 and the log group, also the fuse side calculation, also the cable selection. So I talk about the AR3008, table 1, 3x1, 3x2, 3x3, 3x4, and then we can determine the size of the cable. And then although you got the appropriate size of the cable, and we agree with the first formula, IB less than IN less than IZ, it does not agree with the I2 less than 1/4 by IZ. In this case, why we can say we are using the HRC fuse. We determine the for loop impedance by using the table 8x1, and the sublight voltage by a for loop impedance current is at 35.9 volts. So this current, and then also the from substituting the formula, we must calculate the IZ value. IZ value is 24/8. This 24/8 is not agree with the 115 millimeter square because of the current only 40 ampere. Therefore, we go back and look at the tables AS3008 table, and then we can determine the appropriate cable size. So this lesson, we explain about the cable selection as well as the maximum demand calculation, and also the coordination with the protected devices. Okay, this is for the electrical engineer practical. And then also we can talk about the electrical trade practice. Electrical trade practice part 1, we also talk about. Electrical trade practice part 1 for the lower level trade course. So the last time we talk about we finished the 32. So then now we finish the page 33. This is for the higher levels electrical trade practice. So we're talking about this pollution control. Pollution control means environmental factors, hazardous factors are the affected, or the environmentally hazard chemical that are also included in the pollution control. Also the pesticide as well as the combination of the land management act on the protection of environmental operation as those factors are affected on this influencing the pollution control. So therefore before you are doing the ND's operation, we have to see this rate analysis, whether consequence or the likelihood happen. So that things are there you have to find out. So the workplace environmental risk and the resource efficiency important aspect. So typical issue related to the deposit of the waste and the pollutants are focused around the electrical equipment. So that when you are using any electrical equipment, appropriate pollution control must be regarded. So deposit all the packaging materials, because of all the packaging materials are the insulation plastic, they need to be disposed properly. Deposit of the spent glass, mercury, frozen lamp, and segregation of the waste in the bin, unnecessary packing. Also deposit all the scrap and the liquid waste, purchasing of the environmentally sustainable appliances, and minimize the vehicle use, cleaning the fluid, clearing the workplaces. Those are important for the environmental control. So those are the pollution control is most preparable means that we have to avoid, and also we have to reduce, we have to reuse, recycle, recover, treat, and then dispose. Those are the preparable method. The most preparable we have to avoid, and then reduce, reuse, recycle, recover, treat, dispose. So those are preparables are steps. So falsified fuel and the environment. Falsified fuels are the finite pressure, energy, security is to be converted, concerned. The use of the fossil fuels change the climate because of they are producing a lot of greenhouse gas. Also, they are increasing the production of carbon dioxide and to causing the greenhouse effects. Therefore, the Kyoto Protocol is the aim to reduce the greenhouse gas emission to reduce the temperature rise to the certain limit. So this is the ways we are need to follow the Kyoto Protocol. And in this case, we are using the use of the renewable energy. Use of the renewable energy such as the solar, wind, hydro can reduce the use of the fossil fuel. So this is for the important. Another thing is that we also have to utilize the energy efficient devices. So energy efficient is a building system. We are using a building system. We use the energy efficient lighting system. So the building system, we use a maximum demand, nature energy such as a solar and the wind to illuminate and circulate the air. They are important aspects inside the building. Instead of you are using the fan or the air conditioner, the nature air circulation in the building is the most healthy, also the more energy efficient. So this is the ways use of the fossil fuel need to be reduced. The equipment which consume the less input energy are preferred. So we are replacing with the less energy usage equipment. So this is the electricity in Australia. Electricity is generated by the coal-firing power plant. So that you are using the more electricity, it will fire the more coal and the more pollution can happen. Therefore, the energy reduction is also important aspect. So that by applying the energy efficient building design system and using the energy efficient equipment, we can reduce the electrical power generated by the coal-firing power plants, which are producing the greenhouse gases. So the renewable energy power plants such as the wind turbine and the solar electrical system, they are either to provide the energy security, in the meantime reduce the greenhouse gas they produced by the coal-firing power plant. So this is the ways we are talking about the energy efficiency. So the energy emergency lighting system, then I will talking about the emergency lighting system. Emergency lighting is required in the most of building to protect the human rights. So this is emergency because of in the case of any fires or emergency, the building electrical power will be shut down. In this case, we have to provide emergency lighting. So at least all the stairway, escape route, they must be provided with the emergency lighting system. So the building code of the Australia BCA, Workplace Health Safety Act, and the various industrial requirements, the state that the evacuation system must be installed in all sub-buildings. So the emergency lighting is provided for the emergency evacuation as well as to avoid the loss of the power and the light in the critical operation. So this is the importance of the emergency system. So therefore, the emergency lighting systems, we are utilizing the emergency lights. So that we follow the system need to be supplied with the emergency electrical supply. In this case, we have to use the mechanical ventilation, access and egress, and installation, fire the system. Those things are requirements for the emergency system. So the building code of the Australia, Part A3 is explain about the building classification. Part E4 is the emergency lighting, and A6 sign requirements are provided. So that there are the appropriate Australian standard for the emergency lighting system. Is and SS 2293.1 1998 edition is a system design, installation, operation. AS and 27932, so 95 is an inspection and a maintenance. AS and 22933, 1995 emergency luminous and the exit side. So those are the Australian standards required for the emergency lighting system. So the kind of the emergency system are they are self-contained or the centralized system. Self-contained is an individual luminous are equivalent with the self-contained battery and charger. So their advantages are the flexible, simple mounting, simply connected to the local lighting unit circuit, multiple battery for the main power failure, and disadvantage they are high cost. And centralized system, all the emergency systems are connected to the emergency power system. The advantage is reduce the maintenance and less expensive, but the disadvantage of when the fire happen, those are given need to be have the fire rating. We might use the MISS given methods insulation miners sheets are given have to be utilized, and also they must have the fireproofing. So this is the installation of the emergency system. So this will be the kind of the emergency system we are explaining about. In the event of the emergency system fail, all are operational because of the centralized system is the disadvantage. Therefore, the appropriate level, the elimination level is required for the emergency system. So here is a evacuation luminaire. This symbol as you see on the drawing diagram. This is for the black and white emergency plus symbol. So this for the emergency given. So here is we are talking about the emergency supply circuit. So there will be the battery supply here. So the switch is active, and also the test switch, also test switch and red light, and also this is battery connection. This is the sub connection here. Here is the emergency light system. So this is the emergency battery pack and the inverter we utilize. So the principle of operation of emergency system means that this is where they connected to the supply board here, battery charger, and also connected to the LED indicator, is connected to the battery, and low voltage cut off supply failure sensor, nominal emergency sync over switch, and the fluorescent light. So this is for the configuration of the emergency system. The finally we supply the fluorescent tube, normal supply here, this supply we switch to the emergency and change over, and supply failure sensor, low voltage cut off battery charger. Normally we are charging the battery. And also we're going to do the test switch, bollards, and there's a fluorescent light. So this is the configuration of the emergency supply system. So the emergency batteries are the nickel and the cadmium battery, and DC to AC inverter light battery voltage 0.8 volt per cell. And the normal condition, supply voltage and the supply voltage charge the battery and supply the electricity to fluorescent tube through the supply failure sensor and the change over switch. So when the main supply is off, so the supply failure sensor set is and operate the normal emergency changeover switch to emergency protection. So the battery supply the emergency to fluorescent tube. So this is the way emergency. Therefore, the emergencies are luminaires are spacing. We use an emergency lighting requirement. Every fire isolated stairway, every story of the class 5, 6, 7, 8, 9 floor area more than 300 millimeter square, we had to utilize the emergency lighting. Also, the every passive way and row with the floor area more than 100 millimeter square, external stairway and balcony, we had to utilize the appropriate emergency lighting requirement. So the exit signs are need to be installed at the door, providing direct emergency from the story to the enclosed stairway, external stairway, the horizontal exit. So we had to test this emergency lighting. So daily emergency inspection is we have to check the light. Monthly emergency lighting inspection, we have to check the light and the battery. Annual emergency testing, the 2 tests for 3-hour emergency light. So those things have to be inspected. And respective rules here, we have to utilize the AS/NCS 2293.2 1995 edition. So those are the emergency. So that based on the those emergency system, you have to answer the question: what is the emergency supply system? Write the reason for the emergency lighting. What are the places that require the emergency supply system? Name the 2 kinds of the emergency system and describe the advantages and disadvantages. Sketch the emergency system symbol. Explain the emergency system operation with the sketch. What emergency lighting requirements and where are the places existing sign to be fitted. Express the testing method of emergency system and write the name of the ASET and set rule for the emergency system. Those things are you have to explain. So this is today's trade electrical trade higher speed lesson is we finish up to the page 42. So we explain about the pollution system and also the sustainability practice, how we reduce the waste. Those things we explain about the environment aspect. And for the electrical trade, we're talking about the emergency system. Then we're talking about the emergency workshop. Uh, Electrical engineer workshop Friday, we explain about. So last week we talk about the page 22 finish. We 2 days we about the page 23. Okay, so today's electrical trades are beginner level. We are talking about the manual handling. So manual handling is very important because of the manual handling is used to describe any activity requiring the use of the hand or the body to lift the light or medium or heavy load, shift the position load by the pulling, dragging, pushing, moving, and also the collect the tool and material for the storage to adjust the position of equipment and unload the weight. So those are the manual handling. Manual handling also cover the activities which require the use of the bodies are force. If you are using the operational power tool or the crowbar or the repetitive movement, using the screwdriver or the keyboard activity, they are also the manual handling. So those manual handlings are important aspect because of the it can cause an injury. So the injury caused by the manual handling are the back injury, spine, joint, ligament, muscle, intervertebrated disc. They are can be damaged by the wrong manual method. And handlings or hand and leg injury can happen. Finger, hand, feet, toe, finger can be injured. Injury to wrist, thigh, and ankle happen. Injury to back, shoulder can happen. Bruising to the various parts of the body and abnormal in the wall of the muscle, tissue, and the membrane that normally hold the organ in a place. So those are the damage to the your body parts because of the wrongs and manual handling method. The function of spine is important, very important because of this. There must be the slight involvement in the every muscle at all. So if you are moving the any of the body, it can impact on your spine. The stress on the spine due to the activity, lower spine is very mobile, it bend forward and backward, and twisting can happen. Therefore, the twisting or the jerking while the lifting or the carrying the can injure the small faces and joints in your spine. So the back injury can happen, spine, joint, ligament, muscle, any intervertebral disc can happen. So the hand and leg injury can cause to the finger, hand and two and finger can happen. Injury to the wrist, thigh, ankle, injury to back, shoulder, arm can happen. Bruising to the various parts of the body, abnormality in the wall of the muscle, tissue, membrane, can hold on the organ in a place, can cause to this injury. So functional spine is every moment in the every muscular fault, and they also impact on your spine. So therefore, the twisting, jerking, when you are lifting something, you do not twist your body. If you are twist your body, it can damage it can impact on your spine, and you can get a back injury. Therefore, you have to know about the thing. So that we have to use all the intervibrators these are they are joining the muscle between your spine. So that if they are just in alignment, you can also feel this uncomfortability. So also you can feel the back pain. So therefore, the direct injury are caused by the unexpected happening. For example, electrician walking on the irregular ground, while carrying heavy electrical equipment. You are using a heavy, carrying a heavy electrical equipment, and you are walking on the irregular ground. In this case, you slip, and then you can cause a back injury happen. And also, before this is due to those are injury. Before you are lifting anything, you need to assess. We have to assess the weight of the load. You have to position and the location of the load and also nature of the load. where the load has to be carried or the moved, where to be taken, what are the requirements are you also important. If your load is too heavy, do not leave it alone. You must call someone to help or the mechanical assistant. Keep the load close to your body and maintain the balance. Use your leg if you are weighting something. You have to bend your leg slightly and your leg muscle to take the weight. Do not down on the twist of your body once you have the lift, and always bend your knee when sitting on the load down. So when you are put down the load, you have to knee this your bend the knee and then you then put. So this is the way how you are using the manual handling method. So the alternative manual handling is also important. Alternative manual handling is for the carrying or the moving the load. So they can use it whenever possible to minimize the lifting and the carry bending activities. So no alternative material bending are included lift truck, scissor truck, pallet truck, and also the lever, crowbar. So they are the four-leg, manual four-leg. Also, you are using a lever to take off the thing and a scissor lift truck, pallet truck, and also the pallet truck are utilized to move away the pallet. So then also you use the overhead crane to lift that weight, also important aspect. So the several simple procedure you have to follow your lifting the weight. Make sure that you are standing directly in front of the item you wish to lift. Check the item if the item has a handle when you can use it, and know where you are taking the object before you begin. Position your feet evenly and keep your back straight and stand up tall. Tighten your stomach muscle. Squat to the floor by bending your knees. Do not move your upper body. Take the whole object firmly with your both hands, and also distribute your weight evenly. Keeping the object close to your body. Begin to stand up by straight your neck. Stand up slowly. Do not move quickly or jump around. Doing this, you can walk with your object without twisting the body. If you are carrying a large object which restricts your view, ask someone to assist guide you. When placing the item down, bend your leg, and remember that keep your back straight as you bend the down again, and be careful to lower the inside of the object to flow separately. So who is responsible for the housekeeping? So all staff and management are responsible, and also you have to utilize the appropriate OSHA precaution. So that you are using the any house hollow wall facing, you use the correct PPE. Also before you are doing anything, you have to check the wall for any service, because sometimes you create a thing inside there with electrical cable, it can cause an electrical fault. What are the notifiable incidents? So death of the person or the serious injury, illness, and dangerous incident, they are the notifiable incidents. So the workplace hazard include the physical hazard, so machine, electrical, vibration, temperature. Ergonomic hazard is a round bodies are position and a warm method that can harm the body. Chemical hazard are solid, liquid, solvent, gas. Biology hazard is the body fluids, bacteria, virus, insect, animals. Those are the very dangerous in your workplace hazards. So this is for this. We're talking about the occupational health safety aspect. Also, then we are talking about the tapping and the threading. So here is a V thread, here is a ACME thread, here is square thread, here is a Badawut thread. So here will be their indication on the lead and the pitch. So this is a pitch, this is the lead. So this is the right hand thread, and this is the left hand thread. Right hand thread is that you turn right side, clockwise. Left hand thread you can tighten by turning the anti-clockwise. So you turn the clockwise, you can tighten. This is the right hand thread. You turn anti-clockwise and tighten. This is the left hand thread. So that you are checking any screw page. You are using a gauge. So this is the screw page gauge. You can utilize the screw page gauge to check your thread. Here is a 8-star thread. So this is the stock. Stock here. Inside here is die. You put a die in here, and then we can use a internet threading. So the 8-star threading, internet threading, we can utilize with this die. Internet threading, we can utilize the tap. So this is for the internet tapping. We are a tap. This internet tapping, we can utilize a tap. So the external tapping is you can store and type. Here is a thread. So here is a tab. So you put a tab like this, and then you can thread the hole. So in this case, when we are using the tab range, this is the diagram of the tab range. So when you are using a tab, there are tab bar, intermediate, and the bottom. So firstly, here to here, you can use a tab bar, top one, and intermediate is most of the tapping, and the bottom here you can utilize the bottom internet. So there are three that have to be utilized. So the tapping hole size is equal to the normal diameter minus pitch. This is the way we calculate the tapping hole size. So if you see the M14 multiplied with 2, that means hole size is 14, and here is a 2. So 14 minus 2, you got this 12. So this is the nominal diameter is 14, P is 2, and 14 2 multiplied with 2 indicate that this is for the nominal diameter is 14 millimeter, P is 2. So 14 minus 2, you got the hole size 12 millimeter. So this is the way we calculate the hole size. So the throw fishing is a fishing made through the item to be spotted. Cell tapping screws are used for the fishing into the sheet metal or the timber. Chemical ink are used for the fishing to masonry near the edge. So this is for the thread and the die. So in this case, in the lower level 3 course, I explain you about the occupational workplace safety as well as tapping and threading. Okay, then we talking about the diploma. So we're talking about the electrical trade aspect, electrical engineer practice we finished. Now we're talking about the diploma. Electrical diploma 2022. Then we do the video lesson. So last week we talking about the DC circuit. Now we're talking about the OSS information. So the E11, E117 OSS rate assessment. There's a low body safety. Safety procedure and method. We are talking about. media, you can act. You do not assume. By assume something that yourself, it is a good cause for the media. Do not answer if you do not know. If someone asks you something, if you do not say, nobody never answer it. Because your answer is dangerous to the other. Other people follow your answer, and then your answer is inappropriate. The work procedure, the person can obey the procedure. So please be aware. Understand your procedure, follow your procedure, use the appropriate equipment. And if you are unsure, do not assume, do not answer if you do not know. The test requires visa, key energizing. So if those are switch off the electricity or send it on. All the energy provided within the area must be overlaid. So that not only the one switch, so all you have to see the all switch, how many switches are providing the electricity to the area, all who provide them must be open. And after you got switch off, then you now let the place on the energy to provide it. By knowing, by hearing this one, you can now do the procedure. So the measurement must be done. So the any equipment, it must be checked with the voltmeter. Safety grounding must be done. Qualified inspector inspect the whole area. So that we have to utilize the test instrument. So when you are using the test instruments are actually also important. So instrument need to be there and measure the instruments have been verified and then retest the instrument. So measure that the equipment have been verified and retest the instrument. This is the electrical installation safety. One minute safety audit. If you are going to work in the power station, substation, you need to start with the safety situation in the power station. So that they are nice there, even in the 1 minute safety audit, you can follow the procedure. One, notify the responsible personnel of your presence in the area. Any abnormal sound, slip or ambition or noise. 3. Locate all fire emergency cases. 4. Locate all fire alarms and phones. 5. Inspect all transformer liquids, level, temperature, pressure. 6. Locate station one line diagram. 7. Make survey, long history and night. 8. Survey that all required equipment is readily available and easily reached. 9. Check who's is dead. All route display and other operational flags are properly reset. Those are the 1 minute safety step 9. Use quickly assess the safety situation in the substation. Okay, electrical installation safety. As the electrical company now when you are installing the electrical system, you need to get your system to provide light is very important. Light has to be provided light. In this case, when you apply the appropriate EN Austrian standard for the electrical installation, ESM 3000 standard must be utilized. Especially on the appropriate wire, EVA side, circuit breaker, window, it will be done. So you get to follow the appropriate standard. Installation, appropriate installation procedure, working practice must be utilized. You must provide a safe installation. Calibration, all the protective equipment is properly calibrated so that they can effectively isolate the fault. So those are important. So the engineering is the very latest now. Proper deep testing and physical study on the file shows as across the information to the human phenomena related to the safety. So then, because of the safety, they also related to the leadership. So because of the safety but the work pressure can affect on the person. It can help them, it can feel the sleep, it can like deprivation, fatigue, kind of the environment that are extreme. So because of the two factors, people will use it as more try to mitigate that problem and nutritional problem. They are related to the safety aspect. And in order to get installation safety, okay, so today is we talking about the three lecture. Firstly, I talk about the Bachelor of Applied Engineering degree level. So I talk about the electrical engineer practice. So the electrical engineer practice, I explain about the cable selection and the protection system, arrangement, configuration, and also the maximum demand calculation and the selection of the cable side by using the AS3000 cable 8.1 and cable C1, C2, also the ASB down the 8, cable 3x1, 3x2, 3x3, and 3x4. This is for the electrical engineer. Regarding the electrical trades, a higher level trade, I talk about the environmental and the energy emergency lighting system. And lower level electrical trades, I talk about the occupational health, safety, tapping and schooling. Regarding the advanced diploma, we talk about the occupational reassessment. So those are the this week lesson.